Chapter 1, Section 1 is called Using Similar Polygons. So we start broad and then we'll narrow it down after this section into just triangles. So what is a similar polygon? Similar polygons have two characteristics. One is corresponding angles are congruent, and the second is that corresponding sides are proportional. So the angles always are congruent. If A, B, C, D is similar to, which is what this little symbol means, it's no longer congruent, it's similar, then angle A matches M, angle B matches N, angle C matches O, and angle D matches P. The order's important there, just like it was in our congruent triangles and congruent polygons. Correct. So it's like the thing that's usually over our congruence thing. So these are not exactly the same. It's like a little mini-me version of it, okay? It's a model or a scaled version of your polygon. So the angles will be the same, but the sides will be proportional. If the big polygon, if one pair of sides, if it's double, then it's all double. So if this was 10, then this is 5. If this is 12, then this is 6. If this is 14, then this is 7. And if this is 20, these are not trying to scale, but this is 20, this is 10. So if one pair is given to you, you set up what's called a scale factor, but then you know that all the rest would follow. So these are the way we write proportional sides. AB over MN, again, order of the letters is important, would equal BC over NO, would equal CD over OP, would equal AD over MP.
It can't be DC?
Yeah, no, in between, like this could be BA over NM. Those, the order doesn't matter, but these four letters have to match up. These four, these four, these four. Yeah. Okay, the scale factor is the ratio of the corresponding sides. So if two polygons are similar, then I would take the side length of one of them and put it over the side length of its corresponding side in the second polygon. And the ratios will always be simplified. So if I ask you for the scale factor of ABC, triangle ABC, to triangle EFD, then they're not always going to give you all the side lengths. This time it gave you all the side lengths. I could just pick one pair. So AB matched EF in this order of letters, and 3 would go with 6. So this would be 3 to 6 or 1/2. If I ask for the scale factor of EFD to ABC, now it's the reverse. Good. It'd be 6 to 3 or 2 to 1, which can be written this way or this way. Say that again.
No whole number? Or do you have to write?
No, you'll write it in terms of a ratio. Yep. So you always want to keep that. Good question. You always want to keep that in terms of a ratio or a scale, like 2 over 1 or 2 to 1. Question so far. So the order is important. Pay attention to the orders of these because obviously that tells you what goes on the top and what goes on the bottom. All right, so example 1 says find the scale factor of A, B, C, D to M, N, O, P. Find X, Y, and Z. Find the perimeter of each, and then find the ratio of the perimeters. So the first thing I'm going to do is kind of match up my side lengths. These are not congruent, but AB matches MN. BC in order of the letters here would go with NO. CD would go with OP. And AD would go with MP. This time it's kind of obvious because of the shape. But these shapes can be turned, flipped upside down. So you want to make sure that you're paying attention to either order of the letters or whatever the shape is that it's indicating would be similar. So that tells me that if I set up my ratio, my scale factor, I'm looking for one of those pairs that have both the values. So which of those corresponding sides have a value for both? AD and MP. So I would do 10 to 8, right? Which reduces to 5 to 4. And be careful because remember you want to make sure that you put the A, B, C, D first and then the M and OP. So it can either be written as 5 to 4 that way or 5 colon 4. Those are the same thing.
Is that this, what is that?
That's the scale factor. That's the answer to A. Now B says find X, Y, and Z. So if 10 to 8 or 5 to 4 equals any side in the bigger one on the left to its corresponding one on the right, X is here. What side in the first one matches X? 4. So this goes equals 4 to X. Remember, the order is important. I want to put the bigger one, the left over the right. Okay, I'll go back to that. Then I want to set up Y. So Y is here, which means 5 to 4 would equal 12 to Y. And then the last one, Z is here, 5 to 4 would equal 14 to Z. So I'm going left, right, Lewis.
I lost you a couple minutes.
Okay, so you know the scale factor is 5 to 4, yeah?
Yeah.
So that means any side in the left one over its corresponding side in the right one is going to equal that scale factor, which is 5 to 4. Does that make sense?
Yeah.
So I'm just picking which one goes with which, right? X was here, and X matched 4. So it goes 4 to X equals 5 to 4. God bless you.
Thank you.
All right, now we're going back to, yes, proportions, right? So some of these will be easy, and you'll know, like, oh, I could just double it. Obviously, that's not the case here. What do we do when it's not the case? Cross multiply. So I get 5 times X equals 4 times 4. 5 times X equals 16, and X would equal 16 over 5.
You can leave it as that.
You can leave it as that, or
16 colon.
oh no, this is an actual side length.
Oh.
So we'll do a mixed number, which would be 3 1/5. If you like decimals, that's fine too. 3.2, but it's got to terminate if you're going to do a decimal. So any of these are good. As long as it's simplified.
What would be the ratio of that?
So this is a side length, not a ratio.
Okay.
Does that make sense? Yeah, we're solving for X, so that's not a ratio, that's an actual side length. Okay, then I go to the Y. So I get 5Y. Oh, that's ugly. Equals 12 times 4, or 48. Divide both sides by 5. 48 over 5, which is 9 3/5. Or 9.6. Again, only because it terminates can you do the decimal.
Yeah, because if it went on.
Right, you don't want to round it. You would keep it as a mixed number. Like if it was 9 1/3, you would keep it that way. Questions on that one? Okay, then the last one. Now I've got 5/4 equals 14 over Z, so 5 times Z would equal 14 times 4, or 5 times Z would equal 56. Divide both sides by 5. Z equals 56 over 5, or 11 1/5, or 11.2. Good morning. And C says find the perimeters. So I'm going to fill these sides in because I know them now, right? X is 3 1/5. Y is 9 3/5. Z is 11 1/5. And ask for the perimeter of each. So left side's a little bit easier, right? Let's start there. If I want to find the perimeter of that quadrilateral, what do I do? Add up all sides. So 10 plus 12 plus 4 plus 14. And I get 40. And then I want to add up the sides here. So this is actually when it's easier to keep them improper. If I did 8 plus, and I go back to when it's improper, 16 over 5 plus 48 over 5 plus 56 over 5. The only one I have to change is the 8, right? Which is 40 over 5. So this is 56. 56 plus 48. 104 plus 56 160. And I get 160 over 5, which actually divides in evenly, right? That's 32. You could have also added your decimals, like I could have done, what was it, 8 plus 3.2 plus 9.6 plus 11.2, and I would have gotten the same thing. You could have also added your mixed numbers, so I would have gotten 8 plus 9 3/5 plus 11 1/5. Oh, and I skipped the first one. Plus 3 1/5. Add up all the whole numbers. 17, 28, 31, and then 3/5 plus 1/5 plus 1/5, 5/5, which is 32. So you want to use whatever you're the most comfortable with. Like if you're a decimals person, then do the decimals as long as they terminate. If you're okay with the fractions, go to the fractions, okay? But make sure at least you know how to do those fractions, because if the decimals don't terminate, you have to. Lewis.
Well, the ratio is 5 to 4.
So the ratio from the beginning is 5 to 4.
The bigger one. No, to this one.
We have the perimeters, you mean? We haven't gotten there yet. Yeah. So now I know both sets of perimeters, and the last question it asks, God bless you, is find the ratio of the perimeters. So I'm going to keep it in the same order. And if I did 40 to 32, 8 goes into both of those, and then it's 5 to 4. So what do we notice is true about the ratio of the perimeters and the ratio of the sides? They're the same, which is a rule. It will say that way. Theorem 6.1. Perimeters of similar polygons. If two polygons are similar, then the ratios of their perimeters is equal to the ratio of their corresponding side lengths. So if I know the ratio of the side lengths, I know the ratio of the perimeters, and vice versa. If in this diagram, KLMN is similar to PQRS, then if I add up all the sides, it's going to give me the same thing as if I separate them out. KL to PQ, LM to QR, MN to RS, and NK to SP.
In this case, the smaller sides are on top.
Yep. No, it depends on the order that this is written in. So good question. How do I know what order to set up my fractions? What goes in the numerator, what goes in the denominator? Whatever comes first. Yep. It's also true, like if you flip it, like if I did PQRS to KLMN, then the reciprocals of all of these are still true. It's just that the order of them is going to change. Yep.
In the quiz, if you want us to find the ratio, do you want us to do like the first part, or just to find two different sides?
So it will either ask for the ratio of the sides, or it will ask for, and then it could ask for the ratio of the perimeters.
But you can do like the long way of like finding.
Shh. Not necessarily, because what if I don't give you all the side lengths? Right?
It's not gonna be a question asked when like find each side length and then.
Yeah, no, it could be. It could be just like the one we just did, find each side length, then find the perimeter, but they should be the same. Or it could say find, and you could only have maybe one set of side lengths to get the scale factor, and then automatically know the perimeter without having to know all the other sides. Yeah. All right, this one says corresponding lengths in similar polygons. So if two polygons are similar, then the ratio of the corresponding lengths in the polygon is equal to the scale factor of the similar polygon. So we already established that, right? Whatever that scale factor is the ratio of the corresponding lengths. So in this diagram, it says triangle TPR is similar to triangle XPZ. So TPR is this left triangle, is similar to XPZ. Then it says find the length of the altitude PS. So what do I know about the scale factor? And let's say I keep it in the order of TPR to XPZ. What would this whole side be? 12. What would this whole side be? 16. So what's the scale factor of TPR to XPZ? 12 over 16, which is?
3 over 4.
3 over 4. That's the scale factor, right? So then if I want to find PS, how do I set up the other side of this fraction?
Is it PS?
It would be PS over 20. So the order is important there, right? Because the left triangle has to go over the right. So I can make PS my x if it's easier for you to just make it a variable. I would say 3/4 equals x over 20. And then here's a case where it's probably easier to go left to right. If not, you cross multiply, figure it out. But what do I multiply 5 by to get to, what do I multiply 4 by to get to 20? 5. So I could do the same thing here.
15.
And I get x is 15. If you don't see it, cross multiply. 60 equals 4x. And x would equal 60 over 4, which is 15. So it doesn't matter which one, okay? Our answer would be 15. Camilla.
So this might be a stupid question, but how do we know when to put the x on top? And then
So that's what I was talking about, that the order is important, right? So because we went, it's not a stupid question. Because we went 12 to 16, we have to go left to right. So the same order you went the first fraction, you have to do the second fraction. If I had done 16 to 12 or 4 to 3, I went blue triangle to green triangle, I'd be doing blue triangle, which is 20, over green triangle, which is our x.
So because it says TPR first, you put the unknown variable.
This one, it actually doesn't matter because it didn't say find the scale factor of this to this. The order didn't matter. But whatever I established as my order in the beginning, I have to be consistent to the right-hand side. So both of these are totally right. It doesn't matter what order I did that in. It's just that if I did left to right for my scale factor, I have to do left to right for my unknown. If I did right triangle to left triangle like this one for my scale factor, then I have to do right triangle to unknown for my other side. Does that make sense?
You're still gonna get the same.
You get the same answer.
Yeah, but the scale factor just refers to the sides, right?
Right.
Okay.
But it didn't blatantly say what's the scale factor. If it said what's the scale factor, now it either has to be 3 to 4 or 4 to 3, depending on what it asks. So if it says what's the scale factor of triangle XPZ to triangle TPR, what does your answer have to be?
XP over T.
Which is what?
Over there.
What's the scale factor of XPZ to TPR?
16 over 4 to
Or
3.
4 to 3. That answer has to be 4 to 3. Does that make sense?
Yes.
Because I gave you an order. If it said what's the scale factor of TPR to XPZ, it has to be 3 over 4. But if I'm just using it to find the length of one of the sides, the order doesn't matter, as long as I'm consistent on both sides of my equal sign. Connor.
So because you know the scale factor is 3 to 4, how come you can just multiply that by 20?
How come you can, or how come you?
How come you can? Or can you?
No, you have to figure out what gets you from the, so first of all, you had to know that 4 lines up with 20 and 3 lines up with x, right? You have to know which one lines up with what. And then if there's something that you could say 4 times what gives me 20, that's 5. Then I have to multiply 3 times that as well.
So then your answer would be 15.
So your answer here should be 15. Yes, PS should be 15. Questions? All right, let me publish your